Okay, let's unpack this. Have you ever wanted to quickly grasp the core workings of a complex technology without, sifting through endless documentation?
Uh-huh.
Today, we're doing just that. We've got some fascinating source material insights and practice questions directly from the D-PWF-OE-00 exam for Dell Technologies PowerFlex.
Yeah, and what's really insightful here is how we can actually use these exam resources as a kind of powerful shortcut.
Right.
It's not just about passing a test, it's really about distilling that core operational and architectural knowledge. Our mission today is to extract those vital nuggets of insight about Dell Technologies PowerFlex, giving you a quick but still thorough understanding of its key parts and functions.
Exactly. So think of this as your express lane to understanding PowerFlex, a deep dive tailored just for you, focusing on what truly matters. And just quickly, for anyone curious about the exam itself, our sources give us the basics. It's multiple choice, 60 questions, 90 minutes long, 65% passing score, available in English and Japanese. But like you said, we're going way beyond just the test here, extracting practical, usable knowledge.
Absolutely.
Okay, so let's dive right into some practical architecture. Our sources kick off with a question that really gets at the heart of how a host interacts with PowerFlex storage. It asks about the primary function of the storage data client, or SDC.
Yeah, the SEC.
What exactly is the SDC, and why is its role so fundamental here?
Well, that's a really foundational question. The core insight we get from these materials is the SDC provides the I/O path that enables a host to access PowerFlex storage volumes.
Okay.
So in essence, think of the SDC as the specialized client-side driver.
Yeah.
It's that critical communication channel allowing your application host to send and receive data requests to the storage data servers, or SDS.
Right, the SDS.
Its role is purely handling that data path, nothing else.
That analogy really clarifies it. So the SDC is all about optimizing that specific I/O path. Do people sometimes misunderstand its role, maybe think it does more than just data flow?
Well, absolutely. A key insight here is that by pushing the I/O logic to the client with the SDC, PowerFlex decentralizes performance. That's what makes it linearly scalable,
Oh.
which is, a fundamental difference from traditional storage arrays that often bottlenecks at central controllers.
Right, the bottleneck problem.
And no, like I said, the SDC doesn't store data or manage metadata itself. Its job is singularly focused on efficient data movement.
Okay, got it. So we've established how data flows and gets accessed, but once it's there, how do we keep it secure?
Security, yeah, always key.
Our next insight from the exam sources delves into something critical: data at rest encryption. The sources highlight a customer needing this for PowerFlex volumes and then ask about the integrated product for key management. Which solution is that?
Right. The answer points straight to Dell EMC CloudLink.
CloudLink. Okay.
And the real insight with CloudLink is how it shifts things from, maybe siloed encryption to a unified, centrally managed security fabric within PowerFlex.
Yeah,
Exactly. It's not just about scrambling the data. It's about seamlessly linking data protection with compliant key management, which, let's be honest, is often the tricky part of enterprise encryption.
yeah, managing the keys.
It means peace of mind. You know your data is encrypted at rest, and the key to unlock it is managed just as rigorously.
That's a really crucial distinction. It's not just the encryption, but the management of those keys. Does CloudLink play well with existing enterprise key systems, or is it more standalone?
Well, CloudLink really excels because it integrates natively with PowerFlex to provide that centralized key management,
Okay.
which is vital for meeting various security and compliance requirements. It ensures all stored data on the physical drives is encrypted, so it tackles both encryption and that crucial key lifecycle management together.
Okay, so data's secured. But what if the whole site goes down?
The DR scenario.
Exactly. Our sources next shift to that ultimate safety net, disaster recovery. They ask about replicating critical data from a primary PowerFlex cluster to a secondary one. What's the PowerFlex feature built for this?
That would be remote replication.
Remote replication.
Yeah, and the vital takeaway here for business continuity is that remote replication in PowerFlex allows asynchronous data replication between two geographically separate clusters.
Asynchronous.
This feature is specifically designed for disaster recovery scenarios. It makes sure critical data is available at a secondary site if the primary one fails. It's really a core piece of a robust DR strategy. Lets you define your recovery point objectives, your RPOs.
That really does sound like the ultimate safety net. What are some key things organizations need to consider when setting this up? Maybe bandwidth or those RPO goals?
Well, the asynchronous part means there's a slight delay in replication, right? Which impacts your RPO, how much data you might potentially lose in a disaster.
Right.
So careful planning around network bandwidth is essential. You need to make sure replication can keep up with how fast your data changes.
Makes sense.
It's all about finding that balance between cost, performance, and your specific recovery needs.
Okay. Moving on from disaster recovery, let's talk about routine cluster maintenance, something that can go very wrong if not done correctly.
Oh, yeah, definitely.
Our sources pose a question about safely removing a storage data server, an SDS node from a PowerFlex cluster. What's the recommended procedure? And any horror stories if you try to skip steps?
Well, let's just say trying to pull an SDS without using maintenance mode properly, it's like trying to unplug a running car engine. It usually ends badly for data integrity and availability.
Thanks.
The recommended procedure is crystal clear. Place the node into maintenance mode and wait for the data rebalancing to complete.
Wait for it. Okay.
The insight here is crucial. When you put an SDS into maintenance mode, the system intelligently redistributes or rebalances its data to other nodes within its protection domain.
Protection domain, right.
That's that logical group of SDSs providing redundancy. This ensures redundancy is maintained, prevents disruption. Just shutting down a node abruptly. You're asking for data unavailability. Big risk.
So it's all about those graceful transitions, letting the system do its smart work behind the scenes to keep everything stable and redundant. Really shows the software-defined intelligence at work.
Exactly. The system manages that complexity.
Okay, so from safe removal, let's pivot to growth. If you're running a 2-layer PowerFlex cluster and you just need more storage capacity, what's the right move? And why that specific component?
Right. The answer the sources give is to add new storage data server nodes, SDS nodes, to the protection domain.
More SDS nodes.
And the key insight is understanding which components actually contribute the raw storage.
Huh.
In a 2-layer PowerFlex setup, the SDS nodes are literally where your storage capacity lives.
Gotcha.
Adding more SDCs, which are just for client access, or metadata managers, which handle system info, that won't give you more space for data.
Okay.
You absolutely need more SDS nodes to scale up actual storage capacity. It's fundamental scale out. Add more storage workhorses.
That makes perfect sense. So, want more room, go straight to the SDS nodes. Don't mess with the other layers for pure capacity. All right, finally, let's look at automation and management. What's a key feature of PowerFlex Manager that allows for automated, non-disruptive management? This sounds like an admin's dream.
It truly is. The feature you're talking about is Automated Lifecycle Management, or LCM, for software and firmware upgrades.
LCM, okay.
And this really raises an important point about operational efficiency and, crucially, minimizing downtime in these complex systems. PowerFlex Manager's automated LCM capability is designed specifically to perform software and firmware upgrades in a coordinated, non-disruptive way.
Non-disruptive upgrades. Nice.
It ensures cluster stability, minimizes downtime, basically automates what used to be really risky, time-consuming manual procedures. Hours of planning and careful execution, now automated.
As technology keeps evolving toward even more automation and self-healing capabilities, how might our role in managing these complex systems shift? Maybe less direct intervention, more strategic oversight and design.
Definitely something to think about.
That's it for this deep dive. We hope you enjoyed extracting these nuggets of knowledge with us. Until next time, keep learning.